You will have things that the team would like to do, would like to be good at security, would like to be good at the reliability, would like to be doing high fidelity experimentation, hypothesis-driven development, super slick analytics for user telemetry and all of this. However, you can only really do those things if the lower level needs are being satisfactorily met to a sufficient degree. The problem with small, lifeless and continual improvement is that a big oversized constraint can grow and it can kind of just hide everybody seeing somebody else's problem. You can write the best automation work in the world, but if it's not easy to actually run those quality control off them early in the development cycle, they're kind of like, you're not going to get much value out of them. And the wherewithal to actually run it, to create an environment and deploy it easily, that has become its own thing. That is its own need because it trips into often the infrastructure side of things and a lot of the developer experience. And so it's such a moving thing, it has to be kind of platformized into the organization.
Welcome to the Tech Waka podcast, where we dive into the journeys of New Zealand's top tech leaders. Your host for today is Jakob, bringing you conversations with tech leaders and innovators from across Aotearoa. Join us as we uncover the experiences, challenges, and successes that shape our tech community.
Hi everyone. In this episode of the Tech Waka podcast, I catch up with Myles Henaghan, Managing Director at Wires Uncrossed. We explore his mission to uplift the baseline of software delivery in New Zealand and beyond. We dig into his journey from engineering leadership at Xero to launching an open source model called the hierarchy of engineering needs. If you have ever felt like your engineering team is working hard but stuck in the same spot, this episode is for you. Enjoy. Hi Myles, how are you doing?
I am good. Thanks for having me here.
It's a pleasure. A bit of anecdote for everyone listening. You and I almost started a podcast together with David James and a couple of other people a few years back. I think it was beginning or mid of COVID times. So it's quite funny that you are here now at Tech Waka. So welcome, and I'm really keen to hear about what you've been up to and what are you currently doing and how did you get to the current place.
Maybe it was serendipity or whatever it is that tonight or today is when we're recording this, because maybe it's just was meant to be this way. So I think that when we were talking, I was working at Xero at the time.
You were.
And since then, so back then I was the GM of engineering for one of the engineering portfolios in Xero. It was kind of, I'll come back to it once or twice when we're going through explaining things, but it was a spectrum of, or a mix of different engineering teams that I was leading directly and indirectly at the time. And before that, I'll just go back before I go forward a little bit. But before Xero, there was like a collection of other leadership roles, either technical leadership or engineering roles in New Zealand. I was the CTO of a company called Accordo Group. And then before that, I would sort of flip-flop between heavy technical roles or leadership roles. And as you can tell by my accent, I was not born here, but moved over here in about 2007. And so the software engineering that we're going to talk a lot more about tonight, software engineering, professional software engineering, if you want to call it that, started when we got to New Zealand in 2007. And before that, my then girlfriend's now wife and I, we moved to New Zealand from China. So we had spent about 5 years based there. I was on and off working in different industries, initially semiconductor manufacturing, then PC component manufacturing, optical drives, things like that. And then random startups, Chinese startups doing home theater stuff and this and that. I only bring that up because it's a bit of a backstory as to what came into the hierarchy of engineering needs, which I'm going to talk about later as well.
Oh, yeah.
But back to the future then, I guess, from when we met. So after Xero, I finished up that GM of engineering role and then was fortunate enough to be able to start an engineering practice, which I'd been planning on doing for quite some time before Xero, but everything kind of just came together. We're fortunate enough to start it while working there, and then come back, consulting back to Xero, and then started building stuff with other clients. And today, the day job is I am the managing director from Wires Uncrossed, and so we're our engineering practice that focuses on software delivery acceleration. or more specifically, the uplift of, I guess, throughput and quality while boosting reliability and resilience of the systems that you're in. We do that for a mix of organizations. Some of them are like product organizations, or some of them are technology part of the larger organization, that type of thing. So that's what we're about. We are on a mission, Jakob. And the mission that we have set ourselves is to actually uplift the baseline standard of software delivery in New Zealand, Australia, and beyond, as far as we can get to, time zone and geography considered.
Okay.
Yeah.
So if I understand you correctly, you work with your clients, you join their teams, you try to assess where they are, what the issues are, opportunities, and you help to level up their practices, engineering practices. Is that more or less how you would describe it?
Yeah, pretty much. So there's always one of the two things that people are unhappy with. Either like the sort of, we call it like the productivity or the resilience kind of thing. So they've gotten to a point, usually these are somewhat established organizations or a startup that's kind of figured out what its core thing is. And they just sense that things are getting harder and harder as opposed to easier and easier. So you pour more money in, more people in, but you seem to get like diminishing returns or less bang for your buck coming out the other end. Or sometimes these organizations are doing sort of core line of business type products to their customers, and actual, I guess, quality of service or customer expectations is getting harder and harder to maintain that. Or they're on that modernization journey, so they've realized that they need some level of fundamental change in their systems to actually do what the organization is asking of their technology.
And one of the things that you developed, and I guess you use with your clients, is the hierarchy of engineering needs. And when I look at it, it just reminds me of the Maslow's pyramid of needs that we all have. Can you walk us through that? Your
Sure.
version of the pyramid and what it is, like give us a bit of a backstory maybe.
Yeah, I will do. It is a model, and it is heavily inspired by Maslow, which we can touch on in a bit. Fun fact, on the journey of all of this, had to actually read up a lot of the armchair psychology. I never wrote anything about triangles. That kind of came afterwards. It was just words. But anyways, it's a kind of like a side point at this point. But what I happened throughout all of that career working with different organizations, and now as Wires Uncrossed, we sort of assembled a really strong team of really experienced people who've seen an awful lot of both success and failure. And in our case, the failure is just as valuable as the success, because it's our job to try and spot sort of anti-patterns of things that people are doing, whether they're conscious of it or not, that's getting in their way, and swap them out for more helpful patterns that actually work. In doing that, we just had realized or had to face into this confrontation that there is heaps and heaps and heaps of information and podcasts like we're recording now, and there's no end of material out there to explain the benefits of high-performing software delivery. If software delivery or operating software is important to your organization, if you get that to a high level of performance, which kind of is now defined or can be defined as like continuous delivery, if you get there, then that is a good thing for the organization. Dora is obviously a huge, big contribution to this field, but there is information and research before, during, and after Dora, and it all comes to the same conclusion. And with competing people like, say, McKinsey and open source people, they all agree that high performance is better. And there is no end of good ideas out there as to what to do. We'll have anything from ways of working to team topologies to platform engineering to go to the cloud, this, that, and the other. So there's no shortage of evidence that better is the good, higher performance, whatever you want to call it, is a good thing to go after. There's no shortage of good ideas. But time and time again, we saw teams just not able to apply those ideas or to apply them successfully, or it wouldn't stick. And the model reflects this ongoing pattern that we saw, which is like the actual psychology of what happens in a team when they're under pressure. You can take any team, which is a big part, like a software delivery system. There's the people, there's processes, there's technology, there's goals, there's a whole lot of bits and bobs that go with it. But they're all being pulled and tugged. Then what we realized is that just like in Maslow's hierarchy of needs, you have sort of basic stuff right down the bottom, basic needs for people, It's like food and water. So without those things for a very short period of time, people start to get quite agitated. Without food or water, if you just to labor the point, you know yourself how many hours you would go before that becomes, that's your sole focus. I need to get more of what.
My wife knows that I get very hungry after, probably a couple of hours.
Exactly. And then, so safety is like a layer above that, because the reality is if somebody gets thirsty enough, they will put themselves or their family into jeopardy if they need to satisfy that more pressing need. And it sounds a bit extreme, but you kind of see the same thing happens in certainly many teams, but certainly in software organizations. And so you will have things that the team would like to do, would like to be good at security, would like to be good at the reliability, would like to be doing high fidelity experimentation, hypothesis-driven development, super slick analytics for user telemetry and all of this. However, you can only really do those things if the lower level needs are being satisfactorily met to a sufficient degree. It's not like they need to be gold plated, but you can take a team that at first glance looked like a pretty well set up, hired great people, they know what they're doing, they have been performing well. But if something starts to creak in that team, it might be just like a deployment solution, or if somebody resigns, some key person left, or the opposite, they're having to hire more people and that's actually putting a toll on the team. So if there's a lower level thing starts to aggravate the team, their baseline performance will actually drop accordingly. Sometimes silently, sometimes they'll actually be conscious of it. And so the model that we have open source now is a way to actually start to reason with that. So it's like an analysis tool or a thinking tool for you to actually be able to understand how, if you want to do something higher up, why is it a problem insurers? Are we ready to do that? Is there some lower level needs that maybe we actually have to work on first?
Could you walk us through these different layers of the needs? I think, some people may know the Maslow's hierarchy, but I wonder if you can maybe walk us through your model and maybe just a couple of examples from each of the layers so that people can understand what we are talking about.
Yeah. So we sort of start to depart from Maslow pretty quick after basic needs, but the decision making still influences in it. So of the 5 levels, first level is called basic needs. This is literally anything that any team needs to actually sort of deploy an application change. So make an application change and deploy it into production. This is things like people and purpose, and you need enough people to suit what has been asked of them. Those people need to know what on earth they're there to do. It sounds simple, but if the purpose isn't there, you can just get lots of outputs, but not a lot of outcomes. The technical capabilities. So do the people on that team, are they comfortable using the technology that the work is actually requiring? Or is there some new thing being introduced to them? You also have things like environment management, which I'll come back to as an example. Version controls, you need something to actually manage your code. And you need a local development setup and an IDE setup. And from that, you kind of can just go and deploy it out. There's other things like compute and cloud accounts and I/O. You can, and not many people might talk about it, but it still does happen where people just deploy stuff from their own machines. You don't even need much else. With all of those basic needs, you can go and deploy change. Then the next managed work layer, that is about what would a team need to actually make changes on an ongoing, how can you stand behind your work? How can we have some level of assurance that that change is of a certain standard? How can we coordinate work across more teams? So this is where something like information management. So where is the actual source of truth as to which components are owned by which teams? What's the run books? What's the operational details about how to get information on it? Quality engineering is another one. So this is a step up from basic needs, but just how do you actually get to the point where it's not all of quality, but it's the engineering side of quality. You get your opinions on what tools you're going to use to run change validation across the other test pyramid, I guess, and so on and so forth. Security controls are in this level. So a lot of people might say that why don't security controls, surely that has to be built in from the ground up. But the reality is we've all been there on the Friday of a tight delivery deadline, and the high pressure projects that is behind will ask for an exemption or get a pass, and the security thing will get shunted on to the next opportunity. At managed work, you also got deployment solutions. So that's like sort of pipelines, build and deploy orchestration would be in there, as would be infrastructure of code. And also at this level, you need to start sort of getting some delivery metrics or delivery and operational performance metrics. Because without those metrics, you won't know if you're starting to backslide on is how we're working now still supporting us versus how we used to do it last year or last month.
Okay.
All right. So basic needs, managed work. Next one is effective ownership. So you got a team owns a bunch of components or services. What do they need in place to be able to actually own those services over a long period of time? So forget if they might even have to make a change in it, but this is where you need things like incident management, SLIs and SLOs, or some user-centric measure of whether or not we're actually fulfilling our promises for performance. You need APIs and SDKs to actually coordinate work across teams. Eventing, you can start doing that at this kind of level, so trying to orchestrate platforms or functionality across different systems. And static analysis. So we just have static analysis at this level because it won't really get the oxygen it needs. It'll switch on, those linting tools or vulnerability tools. They'll just send a Christmas tree report that nobody actually looks at. So that's why we move it up to be effective ownership level, where it's appropriate to actually take action. And then that leads into sustainability. So over I would say a multi-year period, a year or longer than a year, what do we need to actually both continue delivering new value while protecting the value that we've already shipped? That's the experimentation, product metrics. You need to get onto some level of continuous deployment at this stage, but you also have a chance to do career growth. So often, the way that you might get an excited, enthusiastic start of, we're going to have junior people rotating through. It was a career progression plan for somebody to, but it always sort of goes in fits and starts, because the idea of growing people and pairing and taking care of their career keeps getting eroded if the basic needs keep interrupting them. And then at the last level is what we call the flow level. So pretty simple. At the flow level, you want to get that proactive and disaster recovery. So all of the things that is in the important bucket, but rarely urgent, those things are actually getting taken care of by the team, and nobody needs to come around saying, thou shalt remedy X, Y, and Z. But they're also able to do true hypothesis-driven development. So they've got all their metrics and experimentation muscle built up, and they're using their time to run experimentation or find out information that is truly new information, as opposed to just going through the motions. And so at the flow level, if it is going well, then your software team or development function, they're delivering new things to customers that are valuable while maintaining, if not improving, trust in things that they've already shipped to their customers.
Oh, okay. That's quite exhaustive list from the sound of it. What part of the model was hardest to explain or to justify to others? Do you have any examples of that?
Yeah, it's a good point. The top and the bottom are easy for people to get.
Okay.
And then everybody will debate on what level other things should be going at and what the name should be. So at the top, that's kind of what a CEO or a board wants to know. We're spending money on this thing. Is it going well? And at the bottom, everybody kind of gets, yes, these basic things, you need those, but the tussle comes in between. And some things, I mentioned security already. Quality was another one. So separating out quality engineering from environment management. So we put environment management as a basic need, and we keep quality engineering as a domain. That one was a bit, not controversial, I guess, but it took a while to figure it out. But the reality is, Jakob, you probably similar to yourself, you'll hire sort of people who are good at quality, whether or not they have that in their job title is another thing. But we can make the best test case in the world. You can write the best automation work in the world. But if it's not easy to actually run those quality control often and early in the development cycle, they're kind of like, you're not going to get much value out of them. And the wherewithal to actually run it, to create an environment and deploy it easily, that has become its own thing. That is its own need, because it trips into often the infrastructure side of things, and allows the developer experience. And so it's such a moving thing. It has to be kind of platformized into the organization.
Mm. And Myles, how do you use this model with your teams or organization? You did mention teams. Do you do it team by team basis? Do you use it on a department basis? Do you do it as a self-assessment tools? Like, do you come in and you assess teams? Like, tell us more about how it can be used in real life.
So we do all of those scenarios that you mentioned. But I think some of them people can use it independently for their own side of things. But it usually starts with some level of assessment. We do it kind of at the organization level. So we kind of delete the org chart as much as we can. And we delete the technology choices that the organization has. We sort of put those off to the side. And our goal, there's like 40 things. We will go and look at the website engineeringneeds.io. There's 40 things on there. But that's kind of like part of the message. There's always just too much to do, which is usually what a technology function kind of knows, but acknowledges to varying degrees. So our job, this is where Maslow sort of gives away to the theory of constraints, if you've ever heard of that. And essentially...
Yep. The goal and all
exactly.
the stuff.
Yeah. So when you actually go to use this, one bit of the kind of realization, okay, there's lots of things, and they are dependent at certain levels of need, and there's some level of interdependency across them. Second thing is the goal, to use the pun, we've got to try and find for any organization 1, 2, or maybe 3 things out of the 40 are their main constraints at that particular time. And so the game is, how do you whittle it down so to get rid of ones because they're kind of okay enough for us, or they're not applicable for us, or it's not really pressing with us. So each one of those things on screen, you and I are looking at a screen, but each one sort of has a weighting. We're not open sourcing the weightings yet, but the idea is for any of those needs, you want to put them on a maturity grading. Are you happy with it or not? We've open sourced a light sort of indicator type concept for each need. So you can go into each one, click it, and there'll be one or more indicators or statements which indicate sort of high performance for that particular need. And so the gist is, regardless of if it's us or people using it independent of us, figure out what maturity each of them needs is at. Then you have to have, sounds simple, but it can get complicated. You got to find out what the technology organization, what the particular team needs to do. Do they need to become more productive? Do they need to scale? Do they need to sort of standardize what they're doing so that they can sort of take on more teams and more people? Do they need to just focus on operational excellence? Or have they got a churn problem? Do they need to just make the actual developer experience somehow better for it? And so you have to put that together, what's kind of expected of the team, which may be clear or may not be clear to people. And then you also got to put in what the organization's striving for. So whether the overall organization strategy is set or whether their priorities are clear or not, you kind of got to guess. You can't wait for it, but you got to guess, what are they more interested in, or what are we trying to optimize for? And then we get it down to 7 is good. So if you can get it down to just 7 things, that's good. With enough time, you could probably get it down to more, but you want to find what are the main constraints. And then usually at that point, you can kind of feel that some of them are just more important than others. And the goal is, how do you get it so that people can use this to prioritize which things they're going to say yes to, and what is the bigger list of things that they're going to say no to for the given 6 months or a year or 18 months.
And who is at the receiving end of it? Is it the team or the manager? Is it a CTO? Who do you give it to?
That can vary depending on the situation, but there are examples where if the CTO, they're like, you've got to do something different, and maybe they've acquired another company, and there's all sorts of scenarios that happens to organizations, and you need a sort of a full reset. That's one teams, the team topology movement that has come on.
Yeah.
So it's quite helpful for that as well, to set a scale across the bottom of the model. And at one side, so going from basic needs up to slow. Basic needs and managed work, they're more good candidates for platform teams and enablement team. versus you want to get more of your stream team focused on the stuff higher up in the model. So if you're in engineering leadership situation, maybe you've got teams of teams, you're trying to figure out, you can't platformize everything, you don't need to, but which ones are sort of actually we're a bit red on that. And if that is a key dependency for some other things, then yes, we should focus on this kind of instead of the other. And then also at a local team level. So if you're in an individual team, often they're not very good patients, for want of a better word. There's other teams supposed to help individual teams. They can look at this and go through a realization of, oh, actually our version control is really consistent. It would be good if that was sorted out. They'll often suffer in silence, but this is helpful to them to say, yeah, okay, here's an expectation of what should be true if computed in a healthy state or a local development is in a healthy state. But if it's a smaller organization, often, we've used this with small teams where it's just a one development team, maybe a 30 to 50 person org. They can quite quickly sit down for an hour or two and get a feel for this quite quickly. It gets where it gives more and more value is when you go into that team of teams or mixed different molds. You got like sort of a greenish fields development and maybe an acquisition sitting alongside like a really old system. Kind of thing.
And you mentioned some of this model is open source, and open sourcing your IP is a bold move. Why did you decide to do it, and what do you think is the aim behind open sourcing it?
Yeah, open source thing. We're figuring this out a little bit as we go. So some people on the team, Paul Merrick and a few others, they've been involved in open source projects before. I've not, so I'm learning as I go. However, the sentiment as to why to open source, it goes back to the mission of what we're on as a company. So we are out there to actually uplift the standard of software delivery in New Zealand and Australia and beyond. We're not going to get to everybody. People aren't going to hire an engineering practice to help with all of those things. So this is part of the mission. We believe it by open sourcing it, at least we can share what we've all figured out already on our mutual experiences. And if you put us all together, we've worked now with essentially thousands of engineers across hundreds of teams in all sorts of different geographies, cultures, and regions. What you see reflected in the model reflects not just the people at Wires Uncrossed, but I would say there's a collection, Jakob, of 12 to 16 other people, called friends and associates who've also contributed to it. It's at version 7 now, but this is the first time that we shared publicly. So right now we're open sourcing what we've been able to assimilate so far. And I guess the bet that we have every time other people get to interact with it or see it, people who have experienced different to ours or in different situations, the model grows through it. And so the idea is that it will become more effective with more feedback and contributions from other people. And then not everybody has to contribute to it. It can just help sort of inform or jumpstart other people's troubleshooting of engineering.
So how people can find it and how people can contribute?
Cool. So there's two different modes, I guess. If you want to just sort of query it and critique it or digest it, you go to engineeringneeds.io. That's probably the best place to go first. And that's where you can see it and step through the different sections of it. And then from that, there's also a link to the GitHub repo that's behind it.
So Myles, I'm imagining now myself trying to use it. So I'm going to that website, and how would I use it? Give me 3 main steps or tips to how do I get started with it?
Cool. Okay. So you want to come in there with an agenda. You'll come into it once and have a look at it and go, what on earth is this? Step 1 is to just broadly familiarize yourself with the different levels of need and what's within it. But then you got to come back into it with an actual problem. So in these cases that are partially what we do with the model, we believe that other people will be independently be able to do. If you're trying to wrestle with your engineering strategy, if you're trying to justify investment in engineering enablement or platform teams, if you're trying to wrestle with your teams have these competing initiatives and it's just difficult to compare one with the other, Or if you're trying to communicate with stakeholders, you've been going in circles to get other parts of the organization or leadership on board with what you need to work on and why. Or lastly, what we found it quite useful for is shared responsibility models. Say you've got your strategy in place, you've already got your sort of platformization or team topology sorted out, you've got some way of prioritizing, but you need a way to figure out the shared responsibility model across different teams. So all those use cases can be done with it. Coming to the problem, I'll stick with engineering strategy for now. You really kind of need to make a diagnosis, and you need to say yes to a very few things and no to an awful lot of things for not now. And you essentially go through a self-assessment type process and then figure out which are the key constraints. And then you then go back and look at all of the initiatives and all of the things that your teams are trying to do. And some of those initiatives are what we call sort of power up, or one initiative that will help multiple needs or multiple key constraints. Those are the initiatives that should get more points than others. So that helps you both prioritize what you want to do and do it in a way, and communicate it in a way that everybody will be more accepting of it, even if their initiative got denied or a no, and your stakeholders or leadership both get it understanding too. However, when you are picking which ones to actually work on, there are new guidelines that's on the website. There's like sort of 6 kind of guides that we've posted out. So if you've got 2 different needs and you cannot do them both at the same time, or they will use the same resources, then the basic needs it's better to invest in the basic ones first before trying to do the higher order ones. Enduring needs. So sometimes people will get fixated on a particular technology implementation for a need. Don't worry about the technology. The need will be there long term. The technology can come and go. Foundations matter. So if there is a higher order thing that you want to work on, just cross-check or have a think about which of the lower needs might actually depend on. And then that might change your weighting as to which ones are more important. Number 4 is contextual importance. So we talked about it earlier, but some organizations, they need to prioritize more operational excellence over productivity, for example, and that can change the weighting of fees as well. Prioritizing lower needs. So yes, the lower needs will always have more impact than a higher one. But then lastly, that's what we call holistic initiatives. So if you have something like, say if you've got a problem with version control and people also are not happy with their deployment solutions, and security is not happy with the level of vulnerability detection, then if you move your version control to a different ecosystem, that will unlock or make a lot of those dependent needs easier to manage.
Okay. And let's say I'm giving it a go and I'm working through it. And what happens if I have some questions? I need some help. Do I go to you guys to help out? Do I go to GitHub? How do I find some help?
Well, we keep it local. However, on GitHub, there is a contributing guide and an issues guide. So that's probably the best thing. Just create an issue or start a conversation, and then one of the team will respond as quick as we can.
Nice. All right. I'm really curious. You've been playing with it for a while, I'm guessing, and you've been using it with your clients. Would there be a story where you really could see some sort of a breakthrough or something that would not be possible without this, or something that, maybe a scenario where it made it really easy to influence or to help your client? Any kind of scenario to bring it to life?
Yeah. 2 scenarios. So one, there's a problem hiding in plain sight. This is a relatively large for Mozilla standards engineering organization. Lots of things going on, too many things. But there was this just general constant pendulum swing between we need to do more stuff and do it faster, and lots of bad things are happening. We need to figure out why the bad things are happening. Pendulum would never stop. It just kept swinging back and forth. And so it's very easy to just, if the organization is not constrained and they can spend money, to just thrash back and forwards in that mode. But before the model was sort of applied to their situation, nobody's really calling out that environment management piece as its own problem. And so that was it. It was like, but we have people who do quality, and there was lots of testing activity happening, but not really the quality assured outcome that they actually needed. And then you talk to each group, and they would also just point the fingers, or our bit's fine, but it's that bit, and you can't do this. And then everybody was stuck in their teeth, Jakob. And so you would often have local optimizations where everybody is working in the best interests and trying to move their part of the problem forward. But the problem with small, sliceless, and continual improvement is that a big, oversized constraint can grow, and it can kind of just hide everybody seeing somebody else's problem. So with that, everybody a little bit right, but when we put it together with the model, it became obvious that this thing about it's not really the test automation that's the problem. It's the ability to run that test automation early and often and making environment management actually a thing, which was the problem. And it was really hard to tackle because it meant a little bit of re-architecting the application to make it more environment friendly, shall we say. Another one, so that's one story. Another one is modernization topping for financial services clients. And we know the story of modernizations. We have the old thing. Do a modernization program, there will be a beginning, a middle, and an end, and then amazing things will happen after modernization. But of course, it's never quite like that. And what we use the model to demonstrate is, I guess, the true cost of ownership. If you want to get to a high-performing software development function capability, that's a great thing to do, because if it gets to high performing, it goes from being just a cost center to a strategic advantage to the company. That's great. However, all of these things, these 40 things, need to have some level, maybe not in a week 2 level, but in your role, you look at those 40 things. If you take maybe a year, all of those topics will come up. And so the team or the function has to have an informed opinion on all of them. And then when you really consider that, do you want to modernize, or how much do you want to modernize, or do you actually want to offload a chunk of your organization to some other solution or platform? Then it's like a reality check for everybody as to how much has to get done to modernize, that it's not just some application code.
Yeah, I think in the first example, when you talk about continuous improvement, I think that's one of the principles. I think it might be from the fifth discipline from Peter Senge and system thinking. And he talks about how small changes can produce big results, but often areas of the highest leverage are hidden. It's really hard to find.
Yeah.
So I think that's what this model could help out to bring them to the light and to the light.
So much is hidden in plain sight. I guess one of the biggest challenges we have, when you're actually trying to apply it, we work in an industry that is incredibly opinionated and full of terminology and models and jargon. And so it's hard, but we haven't found a way to short-circuit confusion. People have to sort of go in and find their bit. They go, oh, you've missed this, that, and the other. But really, it's usually in there somewhere. It's just been phrased a bit different though. But to your point, we have to get through that people can go, oh, I never thought about that particular aspect on its own in isolation. And that actually is a problem, or it's not a problem. And then the conversations still lives on to better level.
You gave me a lot of food for thought, and I think hopefully that's going to be the same for the audience. So if people want to learn more, go to the website, go to the GitHub, learn more about it, give it a go.
Yeah, that's the main thing. So there's 3 of us around the hook as core contributors, and then there's some sort of associates that also help us, but they're friends of Wires Uncrossed to help us as well with putting the site together and this, that, and the other. So,
Great. Right, I think we're going to wrap up here. Thank you, Myles. That was great to hear from you. Great to reconnect, and I'm looking forward to see where the hierarchy of engineering techniques is going to go now that it's open source, and maybe we can reconnect in a few months' time and see what you guys are learning from it.
Likewise, Jakob, that was great. We finally made the recording, did the podcast.
Yeah.
So Thanks very much for that. That was fun. And
Awesome.
we'll let you know how it goes. See you down the line.
Cool. Thank you. Thanks for tuning in to this episode with Myles Henaghan. If you are curious about how to diagnose bottlenecks in your delivery teams or want to explore the open source hierarchy of engineering needs, head over to engineeringneeds.io. And if you liked this episode, share it with your fellow tech leader or leave us a review. It helps others discover the show. Cheers.